Okay, so this is another problem, a level surface problem with a horizontal applied force. And what we have here in the problem is it says a horizontal force of 50 newtons is required to slide. Whenever they give you a force and then they give you information about coefficient of friction, then the number they're giving is not an unbalanced force. It's the force that you actually have to push or pull, which means it's an applied force. If there was no mention of friction, and usually they would have to say this, they would have to call this an unbalanced force or a net force in order for you to be able to immediately go to the formula F equals ma. And notice there's an m there and there's an a there. So I mean, I already have an m and an a, and if I multiply those together, they're not going to equal 50. So this is that's the applied force. And the question is, what's the coefficient of sliding friction? Again, it just means we're going to solve things in a different order. So the picture pretty much stays the same as the last one. We're going to have a surface, and we're going to have an object on the surface, and we know what the mass of that object is, so I'll put it right there in the middle, 12.0 kilograms. And I'm going to have, the object is going to accelerate, so I know that the applied force has to be bigger than the frictional force. And so everything has to be labeled when you're doing these. So this is the applied force. And I know what that number is in this problem. It's 50 newtons. And I also know the acceleration. So the acceleration in this problem is 3.0 meters per second squared. You can tell that I've had this problem up here for a while because I've gone to writing just s squared, and it used to be they wrote sec squared. So this is an old problem. I probably can go back over and just change them all, because this is usually the way we abbreviate meters per second squared today, but they used to do it like that. So we have friction, and then we have the weight and the normal force. So the weight is in that direction, and the normal force is in that direction. They're going to be balanced once again. So you've got W, and you have Fn. So, and the unknown in the problem, which I don't have on the board yet, is mu. So that's going to be the unknown. All it means is things are just going to be solved in a little bit of a different order, but the picture looks just like the last problem, and the descriptive equations are going to look the same. So when I look at my descriptive equations, I have Fa minus friction equals Ma, and I have, when I sum up the forces in the y direction, I have Fn minus W equals 0. And we're doing all of only one category of problems, so that's why everything looks the same. In another problem, the picture will look different and the descriptive equations will be different. But I'm taking it one type of problem at a time. So I'm just going to solve things in the order that they can be solved. And so what's the first thing that I can solve here? The weight. So just like the last problem, so, you could have the weight as the unknown, or the mass could be the unknown. Anything on this picture. So notice there are 7 things on here. 1, 2, 3, 4, 5, 6, 7. And if I could give you 3 of them, and you could solve for the other 4, but any one of those 7 variables in this problem could be the unknown, including M, including W. So W equals mg. And that's going to be 12 kilograms times 9.8 meters per second squared. And that's going to equal what? 118? Okay, 118. So now what do I know, now that I know the weight? Yep, the normal force. So Fn equals weight, so it also equals 118 newtons. Now what can I solve for? Friction. But I'm not going to solve for friction. I'm not going to solve for friction with the formula friction equals mu Fn. I'm going to solve for friction over here because I now know that, and that. So I'm actually going to use these three to get friction. So if I take this equation here and I rearrange it to solve for friction, I'd basically be putting friction on the other side and Ma on that side. So my equation for friction is going to be Fa minus Ma. Does everybody follow that, where that comes from? So again, friction would go on one side, I'm putting it there, and then on the other side I'd have Fa, and when I bring Ma over, these are all terms. So when I bring the Ma over, if it was positive on that side, it's going to be negative on that side. So Fa minus Ma. So now we put in the numbers. So for the applied force, we know that's 50 newtons. For M, that's 12 kilograms. For the acceleration, that's 3 meters per second squared. And so solving that, and 50 minus 36, so 14. So 14 newtons, there's the friction. Well, now the only thing left to solve for is mu. So I'm going to rearrange the equation. Friction equals mu Fn to solve it for mu. So that's going to be mu would be friction divided by Fn. So I have those two numbers. I can just put those in to get the answer. So mu is going to be 14 newtons divided by 118 newtons. And 14 divided by 118, I hope is 0.119. Since that's the answer I gave you, 0.119. That's the answer for the coefficient of friction. So, looks very similar to the last one. It's just things were solved in a little bit of a different order.